One of the challenges to the muscular system, at least the lecture portion, the physiology of it, when you're taking an anatomy and physiology class, is understanding two things. And in this video, we'll kind of talk about the structure of muscle tissue. And then in the next video, we'll kind of talk about what's happening internally on a micro level to lead a muscle to contract. So let's talk about the structure of muscle tissue. Muscle tissue has a very unique structure to it. It's specifically skeletal muscle, right? Skeletal muscle is made up primarily of skeletal muscle fibers. We call them cells, we call them fibers. The reason why they call skeletal muscle cells fibers is because they look like a fiber cable. They're cylindrical, they're really long. They go from end to end. One end attaches to one thing, another end attaches to another. So they end up calling them fibers, just like they would like some type of cord or rope. When you look at skeletal muscle, it just looks like this big lump of flesh. But when you get down to it, you find that these individual muscle fibers are in bundles. And these bundles are called fascicles. And then you take bundles of fascicles and you put them together, and then that makes the individual muscle. Now, when these muscles work for us, usually the skeletal muscle that we look at in these classes are running kind of in a way straight, right? So it's like having a rope tied to a tree and then you're pulling the other end. And so just keep in mind that it's something that's straight that you're pulling, and that you have them in big bundles. And depending on how much force you need to generate, that's how many of the individual fibers and individual bundles you're going to activate. So something as simple as me writing my name on a piece of paper, I'm not going to use a whole lot of muscle fibers to do that. I'm not going to use a whole lot of muscle fascicles or muscle bundles to do that, because that's a very fine motor movement. That's a detailed movement, doesn't require a lot of power, doesn't require a lot of strength. But if I'm picking up a really big box, like a box that weighs like 60 to 70 pounds, then when I go to lift that box, my body is going to activate a lot more muscle fibers and a lot more muscle fascicles. I might even use the same muscles that I was using to write my name on the piece of paper, but I'm going to activate way more fibers and way more fascicles to do this. Now, the reason why all of this works is because your muscles work off of primarily off of a pulley system, right? Usually when you study musculoskeletal anatomy, you'll find that a lot of your muscles have what's called an origin and an insertion. The origin is where the muscle originates. It's the part of this process that's going to primarily remain stationary. It's not going to try to move. And then the insertion is going to be the other end of the muscle. That end is typically attached to something that your body actually wants to move. So the origin typically stays still, or it uses the origin as an anchor. And then the insertion is the end that is getting moved. One of the big differences also about muscle tissue and other tissues is that muscle doesn't directly attach to most of anything. It attaches to things using a piece of tape, or I should say a piece of duct tape. We call them tendons, tendons, tendons. And a tendon is made out of dense connective tissue. So you've got this dense connective tissue, dense regular connective tissue. And the dense regular connective tissue attaches to skeletal muscle tissue to a bone or another muscle. All right. So when those muscle fibers pull, they are pulling the tendon. And when you pull the tendon pulls whatever it's attached to. It's kind of like if you had a rope wrapped around my waist and I was holding hands with a bag, right? If you pull me, then you're ultimately going to pull the bag because I'm holding on to the bag. Same thing happens with your muscle. The muscle ends up pulling, and it pulls the tendon, and the tendon is attached to whatever it's attached to, and it pulls whatever the tendon is attached to, and it generates movement. It's just that simple. Like, there's very little more complexity to it than that when you're talking about the macro anatomy. Now, when I'm talking to my muscle cells, this is when you're going to have motor neurons talking to my muscle cells. Now, if you haven't looked at the nervous system, then what I'm about to say is like off the deep end. And I'm going to explain this again in the second video. But you have these motor neurons, which are a part of your nervous system, specifically the peripheral nervous system. And these guys, they send signals to your muscle fibers. And once they send signals to your muscle fibers are then stimulated to do this contraction job. And when they contract, they pull the tendons, and then the tendons pull whatever they're attached to, and then you get body movement, because we're just talking about skeletal muscle tissue right now. An example of this is if I reach over to pick up the remote for my TV. If I go to reach over to pick up this remote, I have muscles that my nervous system is going to talk to in my arm. Those muscles are going to contract, or when I say contract, they're shortening. So the muscle cells shorten. Depending on how heavy this remote is, which this remote is really not that heavy, it's only going to discuss this with only a few fascicles and only a handful of muscle fibers, because this television remote is relatively light. But I'm looking over here at one of my travel bags, and that bag is heavy. It's got a lot of stuff in it right now because of a trip that I just came off of. So that bag's pretty heavy. So ultimately, I'm going to end up signaling a lot of muscle fibers and fascicles to lift that bag and to hoist it up and put it on my shoulder. When I'm talking to my muscle cells, I need to keep my muscle cells separated, because I don't want to stimulate the wrong number of muscle cells. If I really only want to pick up a toothpick, I don't want to pick up a toothpick with the strength that is required to pick up this heavy bag. Otherwise, it's going to be a very awkward experience. So I keep my other muscle fibers and muscle fascicles separated and insulated by other connective tissue. So whereas I have fascicles, which are bundles of muscle fibers, I have fascia. And fascia is a type of connective tissue that keeps my muscle fascicles, my muscle fibers, and the overall muscle organ separated and isolated from other tissues. This is how I make sure that when I send neurotransmitters to stimulate my muscle fibers to contract, that I'm only stimulating the cells that I really wanted involved in the first place, and not anything else. That way I can have fine-tuned motor responses to whatever I need to have a response to, and it doesn't go over the top with anything crazy. So this fascia is wrapped around the cells, it's wrapped around the individual fascicles, and it's wrapped around the muscle organs themselves. Your muscles can experience fatigue if you continue to send them signals and continue to work them. And maybe if you want to know more about that, just let me know in the comments below, and we'll make a video for that. As you can tell, speaking of fatigue, I'm pretty tired. So I'm going to go ahead and get done with this video so I can rest my own muscles. If you liked what you heard, please like this video, share it with a friend, and if you haven't already, subscribe to the channel. We'll talk to you next time.